Hello, today I'm talking about processing data, the biology kind of version of that and the physics chemistry version of that. They are both quite different. So in biology, you get a bunch of data, you put it into a graph like this, and you have error bars. We use standard deviation to calculate this thing called standard error. Standard error helps determine the range of accuracy, aka the error bars. This is the formula for standard error. You can see it's the standard deviation over the square root of the number of data points. So when you graph this in Excel, you can get like an R squared value of around 0.5, and that's okay in biology. That is not okay in physics and chemistry. So the reason for that is there's a lot more variability in biology. Like if you're looking at bees, there might be the species, there might be the habitat, there might be the food, there might be the ground, there might be the sunlight, it might be the wind, there might be lots of variability. So yeah, error bars are the standard error that you calculate. Physics, chemistry, very different. You'll have a graph like this, like current versus volts. We find repeated measurements, so you'll do like 3 trials or 5 trials, and so you've got like a range. So you've got like the maximum of one trial, minimum of the other trial. And so you're calculating the error, which is one thing. Different to standard error, this is the error. It's based off the real value, so past experiments give us. The example I love to use is the gravity acceleration constant, which is 9.8. So doing your experiment, you might get 6 instead of 9.8. So that's the error. It's like that difference between the 6 and the 9.8. Real versus calculated. Uncertainty is different again. So in physics, chemistry, you got error, you got uncertainty. It can be around the mean, or it can be uncertainty of the experiment equipment that you're using. Uncertainty around the mean uses the range of data. When we're graphing in Excel, you kind of want to get that R squared to be 0.9 because you're hoping to have a lot less variability. You're hoping that maybe just one thing is affecting your data, not like biology where there might be 10 things. And the error bars are that uncertainty that you calculated, that range of the data, the maximum, minimum divided by 2, very different to biology. So try not to get these two mixed around, don't use them. Don't use the physics method in biology, don't use the biology method in physics.